Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. We are excited to have a really wonderful guest today. Tom Malterre is here with us. Thanks for joining us, Tom.
Hey, it's a pleasure to be here with you both. Thank you so much for having me. Thank you.
Tom, I first met you years ago at an IFM, AFMCP.
Yes.
This was, I believe, in 2016, maybe 17 in Washington. And I ran up to you and I said, hey, you're awesome. I've heard about you for a long time. So I'm really, really excited to have you here with me on the podcast with myself and JP. And thank you for joining us.
Yeah, I remember that, man. That was right after my detox lecture at the AFMC.
That's exactly right. I was learning all about the beginning. This was my intro into functional, and it was your lecture really stuck with me. So it was a really wonderful opportunity to learn.
Do you remember my little receptor dance?
Absolutely, I do.
Yeah, we were talking about information. We were talking about, how certain molecules will bind to an enzyme based on the conformation of the enzyme. And when those enzymes were, not in the right shape due to lacking of coenzymes or cofactors, then, they didn't function very well, and or genetic variances, right? So when the body makes a specific protein, and enzymes are very, very active proteins, it has to have that right shape, from the genetic transcription factor that occurs. And if it doesn't have that right shape due to what we would consider mutations or SNPs or whatever you want to call them, then, it can't do its job very well. And then you partner in with that a nutrient deficiency, and then that enzyme just doesn't work very well at all. And it's interesting because, it happens in every tissue, organ system, anywhere that's occurring all the time. So you always have a genetic component. You always have a nutrient component of cellular function. And that's what I was trying to get across in that lecture.
I'd love to dig into that in particular. Being a functional medicine practitioner, being an educator in this space, obviously, you were very well versed on the nutrition aspect. You wrote a book a while ago, co-authored The Elimination Diet.
Yeah.
Would love to hear a little bit about kind of the concept of the elimination diet, something I'm aware of, but our listeners could probably learn a little bit about. So why don't we start there?
Well, the interesting piece is, in functional medicine, we're always taught to simplify, right? So we have these incredibly brilliant founders like Dr. Jeffrey Bland and, people who have been contributors forever, like Dr. Sidney Baker. And they really kind of get back to the roots of what disease is, right? Disease is primarily caused by two things, according to Dr. Sidney Baker. One, you're getting too many things you don't need. Two, you're not getting enough stuff that you do, right? So you have this imbalance. There's an unequal equation happening, right? In that you have too many things like we're dealing with these days, like environmental pollutants, toxins, whatnot, really skew the playing field for us. So many of us are inundated with lots of different things we have to deal with on a daily basis. And so it overwhelms our immune system and we become taxed. In the process, also, we've been exposed to a lot of chemicals. We've been exposed to antibiotics that have created an imbalance in the microbiome, or what should be considered the microbiota, but everybody uses the term microbiome. The microbiota themselves are normally fairly protective. And when they become out of balance, we cannot digest our food very well. We can't produce very beneficial amino acids in our intestinal tract very well. It's wonderful. I've examined actually the RNA of certain genes produced by microbes, and it looks like they get in these little groups, to kind of produce vitamin B6 and folates. And it's pretty fascinating how they benefit us in so many different ways. So if you get a lot of chemical toxins and you get an imbalance of microbes, what happens? The intestinal lining becomes unhealthy many times. And when it becomes unhealthy, then it allows for a permeable gut to occur. And then when we consume food particles that can get through this permeable gut and into the bloodstream, then the immune system is quite confused by those food particles. And it says, normally I would love to see a single amino acid. I'd love to see tyrosine or lysine or phenylalanine or something. But instead, I'm seeing these, 17 meripeptides, 32 meripeptides, whatever it's seeing, right? It's seeing all these different structures. And then it's like, whoa, I need to attack that, right? So you start reacting to your foods. So it's quite common these days that many people are reacting to foods. And the specific foods that people are reacting to are usually those that do not digest very well, with, eggs with its lysozyme, or dairy, which has a high calcium level, which buffers acid and then allows the dairy proteins to make it through undigested, or gluten itself, which has specific bonds of amino acids that are very difficult for our enzymes to break. So gluten, dairy, eggs are very, very common food sensitivity foods. So you have a person who consumes this, and I was noticing this. It was the most bizarre thing in clinical practice, where you're taught in graduate school, look out for foods, and foods are a big thing, but you don't really get the power of that. You don't really understand that until you start seeing clients. And so I, myself in 2004 went on elimination diet, and I had terrible joint pain. I had massive fatigue. I had GI upset. It was terrible. IBD, IBS like symptomology for me it was alternating with terrible GI symptoms. And, I just went on a 2-week elim diet and took out all my wheat tortillas that I was putting my burritos in, and all my symptoms went away. And more importantly, it was the mental clarity and energy piece. So I've had a history of having ADD, ADHD, like, I want to do a million things all at once type of thing, where I just get excited about everything and I'm just all over the place. And, I had clarity all of a sudden, and I was like, whoa, what is this? And then my mood level was like, the world's so beautiful, man. Look at all these leaves. And everybody's so great. It was like I was on a drug or something, right? And so I said, I want that. So I figured out that once I added back in, the wheat products, that disappeared. And then I fine-tuned it down. It was wheat and dairy and some other things. But I was like, I got to share this. I got to get this out. And so I started recommending it to my clients in the clinic when I was still a student at Bastyr University, and I saw these miraculous changes. People had rheumatoid arthritis for 31 years. It was gone overnight. They didn't know what was going on, and just all these miraculous things. And so I thought it was my responsibility to reach out and write a book about the elimination diet. And since there was no book at the time titled The Elimination Diet, and I was learning from some of the world experts in the elimination diet, whether it was the Jeffrey Blands or, Jonathan Wright and others, Alan Gaby. And so I was like, wow, let's do this. And I put it out. And since then, the feedback has been just phenomenal. I mean, you get people from the Middle East emailing and saying, my psoriatic arthritis, my psoriasis is gone now. I've had, migraines, I've had whatever. And it's just fantastic. So I feel really blessed that I was, number one, taught that information. Number two, from external sources, all these brilliant minds that I've been exposed to, but also from my own experiences. And now I'm being taught on a daily basis from my own clients all the time how, this is incredibly important. It's affirmed daily to me. It's like, do not pass go. So I was just interviewing Terry Walls. I don't know if you know Terry Walls, right? She reversed her MS and
we just had her on the podcast, actually.
Oh, fantastic. Yeah. Well, guess what? Terry and I met at the IFM conference. I handed her a copy of my book. She was doing our cookbook, Allie and I's cookbook, and Nourishing Meals is what it was. And that was the Whole Life Nutrition Cookbook. Anyway, she decided to do all these gluten-free, dairy-free recipes, and she found out that the gluten-free, dairy-free diet was incredibly helpful. She also did paleo. She went on to do a lot of different things. But a lot of people will tell you now that, don't pass go until you've tried a gluten-free, dairy-free diet. You talk to practitioners in Germany, they'll say 80% of my clients get better on a gluten-free, dairy-free diet. You talk to Mark Hyman, you talk to all these bigwigs, everybody will say, gluten-free, dairy-free diet, let's give it a go. And then from there, we can fine-tune, once we figure out the food sensitivities.
Love it. And it's so interesting to hear, essentially every person who's gotten into the functional medicine space, gotten into this nutritional therapy space, often has gone through their own challenge, has gone through their own changes. Oh, sure. It's the same thing for me as well. So hearing each journey is very unique and very exciting. I want to take the next step in your journey as well to go on to what are some of the things that you started working with in clinical practice, a little bit more specialized?
Yeah, thanks. Well, I've migrated depending on where my interest is. So I started out in autism research. I have a Calabash niece. My best friend died in a car accident. And so his niece actually glommed onto me as Uncle Tom. And so she would ask me all these health questions. And her son was diagnosed with autism. Wonderful, wonderful boy. He's super functional now. He's great. And, you get fascinated and you start doing research, right? So you start looking at all the data from Martha Herbert from Harvard and as a neurologist, and what is she finding? And Richard Deeth and Chandra Jill James. And you pull all these articles and like people are infatuated with sports stars. I'm infatuated with researchers, right? So I will look at their data and I'll say, like, these people are changing lives. Look at this. I mean, they're reversing autism. How in the world are they doing this? And so you dive into the mechanisms, you dive into the research, you go to the conferences, you try and train as much as you possibly can with these people. And then Kismet has always put me in the right place at the right time, right? So I'm heading up to my hotel room and Martha Herbert's heading down to the restaurant. She comes out of the elevator, bumps into me. Oh my gosh, you're Martha Herbert. Blah, blah, blah. I'm such a fan. Can I talk to you about your research paper? And she says, come have dinner with me, right? And so you meet all these people and you have these conversations. And next thing you're teaching their information to the public because maybe how you teach is more understandable than somebody who's immersed in the neurobiology all the time. So, I got into autism for a while. And then from autism, it was interesting. I got over into Alzheimer's disease since there's a lot of crossover in brain. And from autism, of course, you always get into detox, right? Because you look at the immense amount of chemical exposures that people have. And you see that the tightest correlation when you look statistically is between phthalate exposure and autism, which is interesting. But then there's also now this new microbiome data in autism. So you learn about the microbiome. So I got into brain stuff and Alzheimer's from there. And then I also got into the microbiome. So I was working for a startup with Alzheimer's doing the Bredesen protocol. It's called Enso Health. And then I was working on the microbiome and I got pulled into Viome, that company who looks at, the actual gene expression of bugs. And I got to see like pathways that would blow your mind, right? So about how these different things interact to create a synergistic life. And I have to combine those two right now and give kudos to a gentleman whose name is Rodney Dietert. So it's interesting. Rodney Dietert was saying, I got approached Tom by Entropy, the journal, to publish an article. And I'm an immunotoxicologist, right? He's Cornell. And I wanted to really talk to people about how, this terrible air pollution and these plasticizing agents, endocrine disrupting chemicals are changing in utero development. And what I was on my way to do was write this brilliant paper on toxicity. And I fell asleep one night and I had a dream. And in this dream, my mom was talking to me about all the bugs. I believe it was his mother. Was talking to him about all the bugs and how the bugs in the environment are affecting everything. And so I started looking into microbiological influences on detoxification, on neurological development of children, on all these different aspects of programming health further on, talking to the immune system, training the immune system. And instead of writing an immunotoxicology paper on environmental toxin exposures, he wrote a paper called The Completed Self, where he said the human body is not yet complete until it actually is inoculated and colonized with a lot of the microbes that the mother had been exposed to through their entire life. So through the birthing process, you come out, you're getting it in the eyes and the skin, the nasal, cavity and in the oral cavity. And then you then populate yourself with these organisms. And these organisms then train your immune system, literally train your immune system on how to exist and survive and thrive in the environment. They train your body on how to produce, train fellow microbes, how to produce specific organisms. So they protect your body against viruses, parasites, bacterium, whatever might be in the environment that could be potentially harmful. And so he said, look, let's complete humans, right? Let's look at the birthing process. Let's understand that there's this fecal exposure at birth. There's all these, vernix and all these things that occur because you need to have these beneficial microbes around. And then from that, he says, look at this. When the microbiome is in balance, you have 50% less of the toxin exposures. So the microbes actually can engulf and or transform the toxins that the baby might be exposed to. And therefore, you or the mom might be exposed to prior to the baby in utero. So the microbiome itself is probably the most important piece, according to him. So I thought that was a beautiful piece that pulled the two together, right? The environmental toxicity and the microbiome. And he was working on autism research as such. And then from there is interesting because Jim Adams from ASU had taken over and looked at what happens when you do fecal microbial transplantation in autistic kids. So people who had very imbalanced microbiomes, their mothers usually, he says there's a couple of different factors. And mothers usually have imbalanced microbiomes, low fiber intake. The kids usually have low fiber intake, microbiome imbalances, and lots of antibiotic use, and C-section, and breastfed. All those things, or excuse me, not breastfed, bottle fed. So all those things will leave a child more susceptible not to have the beneficial bugs. And therefore, they will have then a propensity for microbe imbalances and therefore autism. And when he was able to give then the fecal microbial transplantation, whether, through the lower route or the upper route, he did an oral version, he was able to have phenomenal success in, reversing some of the autism piece. So it's all interconnected is all I'm trying to say. Whenever you pull at one part of the web, man, you learn about every part of the web, right? So I got into that. And now what's happened is I ended up doing a bunch of nutrient analysis testing and gene analysis testing, right? So I was working to consult with a group of practitioners and in Idaho and teach them about nutrient analysis for 7 months. It was fantastic. And you get to see all these tests, test after test after test when you're coaching other practitioners, right? And then I was doing gene analysis. I worked for my friend Ben Lynch from Strategene panel with Seeking Health, and Ben launched his Strategene panel. And my job was to coach practitioners on how to interpret the panel and what to do with the panels and whatnot. So I went from all these nutrient panels to all these gene panels, and I started to see some crossovers in different disease states, for type 2 diabetes and migraines. And I got fascinated with the migraine piece because, migraines are like a prison. The people who, just one young kid was like, broke my heart, right? You get a young kid who's locked in his room all day long and has to wear glasses and listen to soft music and, can't deal with the world and had to drop out of school. And you see how much life is stolen from people with migraines on a daily basis. And, I've had my own migraines, not as frequently as a lot of people. I've never gotten into chronic migraines, but it knocks you out. I mean, it just completely knocks you out. And your thoughts go to a place where you're like, I can't tolerate this. And some of my clients who are above 21 migraines per month, many of them think about suicide. And, it's its own internal hell of sorts, where it's just something I can't stand as a practitioner to imagine someone suffering from on a daily basis. So when I saw patterns for migraines, I was like, well, I got to learn more. So I started diving into, what's going on with migraines? How can we help people with migraines? And so that's been my focus lately, has been with this program I run called the Migraine Relief Method, is to get people to understand, go back upstream. Right. So one of the most common therapies that are being used right now are the CGRPs, right? The calcitonin gene-related peptide therapies. And these specific medications are geared towards an inflammatory release chemical, right? So when you are experiencing, some sort of irritation to your system, so you're inhaling toxins through the nasal passage, right? And then the olfactory network is bringing those chemicals straight to the brain. The brain is saying alert, alarm. And one of the things it releases is this CGRP. Well, it releases glutamate at the same time, releases a bunch of different compounds. But as it's releasing these neuroexcitatory compounds, these neurodestabilizing compounds, then the brain will respond in a manner that leaves it to become less stable at different portions of the brain, different cells in the brain. But as the brain becomes less stable, it leaves you more susceptible in a state of usually a voltage variation, pH variation, and hypoxia. Then you'll end up with a ability for a portion of the brain to stimulate a pain response. And that pain response is what drives then a migraine. So if we can go back upstream and we can say, all right, where's hypoxia coming from? Why are we getting the initial CGRP issues? Then we can kind of intervene in a way to allow then a more stable frequency for the brain cell. So it's less likely to respond with a migraine. So the reality is when somebody has an unstable frequency, they are more likely to respond to little things. And what you'll see with a lot of migraineurs is, there's this photosensitivity, right? So light's coming in at a certain angle and it changes the response in the brain cell, and they don't know how to compensate, and or blue light at night does this a lot. It causes an inflammatory response. And then all of a sudden it's the perfumes and they're smelling perfumes, or it's, a little bit of histamine in their diet that's a little past a threshold. And there's just all these little things that could be coming into the system that push a person over a threshold and into a migraine. So my job has been to say, all right, what are the things that destabilize the inflammation? How can I stabilize this person? And what are the things that I know of in the literature and whatnot that can lower the amounts of CGRP, that can lower the amounts of glutamate, or help with the body in its processing of excess glutamate, right? To then allow a person to not respond so intensely to their environment. So that's kind of what I've been looking at a lot of.
It's great to hear somebody who's a healthcare provider working with people who have migraines talking so deeply about inflammation, and then walking through how inflammation leads to hyperexcitation, leads to CGRP release, leads to the allodynia, the photophobia, phonophobia that patients experience. And just by putting them together, it explains to people why something that they ate or something that they inhaled or some stressor that they put on themselves, like staying up too late or being in a smoky room or things like that, why those things triggered a migraine. Because you're right, a person who's suffering with a migraine, the World Health Organization considers a person suffering with a migraine to be as debilitated as a quadriplegic. I mean, completely incapacitated. And it's robbing people. It's robbing the economy. I did the calculation. On a daily basis, the United States experiences the equivalent of 3 General Electrics out of the economy because of migraine. I mean, that's a tremendous burden, and that doesn't talk about the people who show up at work anyway and aren't capable of working, and they just put their head down on their desk because they've got a headache, turn off the lights, and try to sleep, but they just want to be present just to sort of check the box that they're there. Yeah. But getting back specifically to the inflammation, because of course the immune cells that are in your brain are the microglial cells,
right?
And activating microglial cells does a lot of things. When they're in an inflammatory state, they're not helping your brain learn. They're not helping to form memories. They're not doing what it takes to sort of ensure that the network is functioning properly. Right. They will also lead to the release of cytokines, TNF alpha, IL-1, things like that have the ability. You were talking about CGRP. When inflammatory cytokines are present, the nerve cells that create, generate, and release CGRP are activated to do that. And you were talking about medications and the use of CGRP antibodies or CGRP directed medications. They tend to be focused on what I consider to be sort of after the horse left the barn.
Exactly.
They're designed to either
go upstream, man,
CGRP or go after the receptor. They're not directed at preventing the release of CGRP or even the generation of the CGRP in those cells. Some of the work that we've done with vagus nerve stimulation appears to be directed upstream, as you like to say, upstream from the release of it, because we can reduce the production of CGRP. We can reduce the release of CGRP by using vagus nerve stimulation, which is pretty fascinating.
Thank you. Absolutely. The piece that I find fascinating too, JP, is that, the vagus nerve is kind of like the stability nerve, right? Maybe you would agree to that. And saying that, you have this turn on switch into an alert and alarm, and you have this turn on switch to rest, digest, detox, repair, right? So I believe, you would know far more than I, that the vagal nerve plays a massive role in this balancing of these two types of systems. And what we see is that, I just interviewed Dr. Kara Fitzgerald, right, who's done a bunch of work on longevity and whatnot. And she made a fascinating statement in an interview she was having. And she said, well, goodness, look at this. We have these genes, they're called the clock genes, that will regulate all sorts of systems in the human body. And these clock gene expressions are modified by stress, and to a point where 25% of the aging process, 25% can be associated through these genes, can be associated to a stress response. Meaning, and then she went on to say, look, what do you think the biggest risk factor is for cancer? What do you think the biggest risk factor is for cardiovascular disease? What do you think the biggest risk factor is for disease in general? And most people would say, oh, it's something like smoking, or it's eating junk food, or what. It's not. It's the aging process. So basically 25% of the aging process is going to be associated with a stress response, whether you're in a fight, flight, or you're in a rest, digest, detox, repair. And vagal nerve stimulation in general would be a direct link to changing that.
We're actually looking at exactly that, looking at the effects of vagus nerve stimulation on the on DNA methylation, on histone modification, and on non-coding RNA, microRNAs, small interfering RNAs, et cetera. Because you're exactly right. If you bring it back around, you were saying, these clock genes and the expression of them is 25% of aging, or maybe even more. And what controls whether or not a cell is going to produce one set of proteins versus another? It turns out, think about it. What makes a nerve cell know that it's a nerve cell versus a fat cell or a muscle cell?
Methylation patterns.
It's the methylation patterns in the DNA. It's actually part of the differentiation process, is the amplification of DNA methylation to sequester the genes or upregulate them. About 5% of DNA methylation is actually to sort of permanently turn on genes. But that methylation pattern, you can track it. In fact, there's a lot of really cool clock diagnostics that they use, where they look at DNA methylation patterns and tell you how old you are based on how well you've maintained the methylation pattern that you need to have to keep those cells in check. Because once you start to lose that DNA methylation pattern, and you lose it from the environment, toxins, infections, stress, all of those things will have an effect on that DNA methylation pattern. As you lose that, and that's true also of your histone modifications, your methylations, your acetylations of histones, all controlling whether or not you're going to be synthesizing and expressing certain genes. If they get, that's what cancer is. Cancer is a turning on of genes that shouldn't be turned on. How does that happen? You lose the control. When you lose that control, all hell breaks loose. And so bringing this back around to inflammation and what vagus nerve stimulation can do, well, if stress equals inflammation, and that's the way I think about it. Inflammation is a response to stress, and stress can be physical, it can be chemical, it can be emotional, it can be mental, it can be simply depriving your body of things that it needs. Any of those stressors leads to inflammation, and inflammation is degrading your methylation patterns. It's degrading the control that your cells have on protein expression, and that leads to cancer, that leads to degeneration, that leads to aging. So if you can block that inflammation, if you can make people more stress resilient without triggering inflammation, it should be anti-aging. And that's what vagus nerve stimulation does. So that's my pitch for the results that are still a couple of years out. But
right. It's interesting to me when it comes to vagal nerve stimulation and or excitation of different areas of the brain, that everything we talk about, right, has a component where it's initiated by usually a cellular stress, right? So whether it's hypoxia or there's a mitochondrial shift that occurs, it's called the cell danger response that Bob Naviau was teaching us at the Autism Research Institute, where when you are in a state of stress, the body shifts from, I'm going to be productive and produce a lot of energy and move forward in life and reproduce and do whatever else I'm going to do, to being protective. So you're either productive or you're protective. And when you're in a protective state, then the mitochondria will use its oxygen to actually not produce ATP. It'll use it to actually combat whatever it thinks it's being under attack from. So it'll produce myeloperoxidase or whatever it can to, push upon the invader, the potential problem. That shift is huge, because if you're not producing oxygen within a cell, then that cell can't do normal immune function. It can't do, normal firing of anything. You name the pathway, it needs ATP to make it happen, right? So the importance in something like migraines for keeping the cells calm can never be understated. I mean, you talk about CGRPs, right? But we said simultaneously there's also glutamate secretion. There's some fascinating trials right now on ketamine, right? And ketamine actually being used to shut down the glutamate excitatory pathway, which is that N-methyl D-aspartate receptor, right? So the NMDA receptor will allow a bunch of calcium influx, and then that calcium influx will excite the neuron, and you're in this constant state of the brain saying, show me where the danger is, right? Or show me where the food is, or show me what I have to remember, or show me I have to be on. How many migraineurs do you know that don't say they're wired and tired, right? Most of them are saying, I can't get to sleep. I've got racing thoughts, and so we think, well, magnesium shuts down the CGRP, and that's maybe why that works pretty well. There's thousands of other reasons that work, and there's different types and different forms of different areas. But the other thing though is we have to think, if we could shut down the glutamate excretion to begin with, right? And we could go back upstream and change that pattern, which is what you're doing with vagal nerve stimulation, then you have one less thing to try and have to neutralize, right? So I would say that, go ahead.
Yeah, so there was a really interesting study that we did back, it's got to be 2014, with Michael Oshinsky at the time he was at Thomas Jefferson University. Developed a model of migraine, which was basically involving exposing the dura of the animals to a pro-inflammatory soup for repeatedly over a period, 10 different administrations over a month. And that would progressively create an allodinic, a permanently allodinic animal. And so what we did was we demonstrated that if you triggered that animal with a stressor that would otherwise trigger a migraineur. So, for example, an NO donor like nitroglycerin or something like that, trinitro.
Sure.
And when you deliver that, the animal has a really robust pain response. I mean, instantly becomes almost frozen in pain. Oof. But what you do is you microdialyze out cerebral spinal fluid from the areas of the brain in the trigeminal nucleus caudalis where pain is processed. And what you find is that glutamate levels are going up dramatically, tenfold over a 90-minute period. And what we showed was that vagus nerve stimulation would stop that. It literally blunted the increase in glutamate entirely, and the animals didn't have that pain response. And then we went so far and said, well, listen, that's great in a lab, but in practice, people don't actually treat themselves for a migraine until after the pain's already started. Right. So can we get halfway up the ladder and see if we can bring it back down? Ooh. And amazingly, vagus nerve stimulation was able to do that. We were halfway up that glutamate ladder, and then we turned on the stimulator, and the glutamate levels came down very rapidly. We're talking within like 5 to 7 minutes. And then just one more thing on this, because I think it's related. What we showed is that same level of excitation that you were talking about, and it's associated with glutamate, is associated with inflammation. And so there's a great paper from 2012. Almost is the author, and has a great picture in there. I talk about it a lot. I mean, honestly, in my world, there's the Sistine Chapel, and then there's Figure 1. And Figure 1 shows the effect of TNF-alpha. And you were talking about NMDA receptors, but TNF-alpha, in the presence of neurons and astrocytes and microglial cells, it causes glutamate to be released from actually, believe it or not, the microglial cell actually can release glutamate. It blocks the reuptake of glutamate and actually causes the astrocyte to release glutamate, which is really weird that an astrocyte would, because astrocytes usually release glutamine back to the nerve, but they're releasing glutamate. And you'd think, well, that's really going to amplify the messaging to the neuron, get it hyperexcited. It does one thing, it does two more things. One, it upregulates the NMDA and AMPA receptors. So you end up with, it's like literally turning up the volume and then putting your hearing aids on max. So you're really going to get all the noise. And then the last thing it does is it shuts down GABA A receptors. So the one last thing you're hoping to be able to sort of neutralize that hyperexcitation is your inhibitory neurotransmitter, GABA, blocks GABA. So inflammation is upregulating glutamate, it's upregulating the receptors for glutamate, and it's downregulating your GABA receptors, which you're just going to end up with hyperexcitation.
Right. Interesting. The fascinating thing to me is you have IL-1 and TNF-alpha as your pyrogens, right? Mm-hmm. So there's a lot of migraine medications that use acetaminophen, and acetaminophen is supposed to be dampening down the pyrogens. However, when you look at the data on acetaminophen, it's not strong. In fact, it's pretty darn poor. And yet we have Excedrin migraine that uses acetaminophen, and at what cost, right? I mean, because we're seeing more hospitalized liver failure issues from acetaminophen toxicity than we are alcohol, right? So it's dangerous if it's taken in amounts that are above and beyond what's put on the label, which happens quite frequently that I see, at least in my clinical practice.
People don't even realize how many things acetaminophen's in. And as a result, they end up giving themselves a toxic dose because they take
meds, allergy meds, seasonal stuff, flu stuff, cold medicines. In the water. It's everywhere. It is literally in the water supply when you test it too. So it's everywhere, right? So that's kind of an interesting piece. What do you suppose, JP, is the reason why acetaminophen, which should be reducing that TNF-alpha you're speaking of, doesn't function? Is it the location in the CNS? What's happening?
So it's actually very interesting because NSAIDs in general are labeled, you'd think as an anti-inflammatory, non-steroidal anti-inflammatory, you would think that it actually is reducing TNF-alpha levels. In general, NSAIDs don't, because there's this tension between your prostaglandins and your TNF-alpha. And so you end up reducing, what ends up happening is if you test after a person takes Advil or acetaminophen, Tylenol, et cetera, what you see is actually an increase in TNF-alpha. So I don't think the mechanism has to do with what the general population thinks it is. I think it has more to do with prostaglandins.
Yeah, well, that's good to know because, I mean, clinically, I want to see the results, but I see so skewed of a risk to benefit ratio when it comes to acetaminophen, Tylenol use in migraines that, there's been enough of my clients that have had massive elevated liver enzymes or some that have had some severe issues. And then I'm not going to say almost all. I'm going to say a lot of people who are consistent with the aspirin, ibuprofen, whatnot. We also see the intestinal problems quite frequently, right? Because you're talking about balances, and that's the prostacyclin versus the rest of the prostaglandins, right? And so you're taking the NSAID and it's cutting off the production of prostaglandins. Yet one of those, PGI, is actually quite protective of stomach lining and intestinal lining. And when you look at the electron microscopic view, within 10 minutes of taking a buffered aspirin, you can see perforations occurring in the gastric mucosa, meaning you'll form pores. You'll make holes in your stomach and your intestinal tract when you take these things, right? I mean, that's like, of course, you're going to end up with more food sensitivities. Of course, you're going to end up with more inflammatory responses due to the perforations, right? So you might dampen down some of the immediate symptomology, but my gosh, what are you doing in the long term?
Absolutely. And just to bring this back around, and really interesting, I had the opportunity to talk to some headache neurologists. And one of the things that sort of cropped up, and I'm always a person who likes to put together patterns and look to see what truth might be behind a pattern. One of the things that I heard repeatedly was that patients who were refractory migraine sufferers, who had real problems, managing them with over-the-counter medications. Triptans weren't working well. They had moved on to even more aggressive drugs. Nothing was really helping, but they swore by Alka-Seltzer. And that sounds almost, I mean, you almost want to laugh about it. But yeah. I said, well, wait a minute, hold on. What is in Alka-Seltzer? Actually, I really have to be honest about how the conversation went, because what I was relaying to this neurologist, where it all sort of came together, was I said, there's a new paper out that says that another way to activate the vagus nerve and to trigger the cholinergic anti-inflammatory pathway is to introduce a basic solution into the stomach. If you can reduce the acidity in the stomach, you can activate the vagus nerve, because of course the stomach is just, I mean, the vagus nerve is the brain-gut axis. It's highly innervated by the vagus nerve. So change of pH is something that you could imagine would activate the vagus nerve. And this paper showed that if you introduced a sodium bicarbonate into the gut, you could activate the vagus nerve. And as soon as I said that, the woman I was talking to, the neurologist, she said, what's the primary ingredient of Alka-Seltzer? And I said, well, I think it's aspirin and sodium bicarb. And she said, oh my God. And then she went on and she said, have you heard about people who use Alka-Seltzer and it's beneficial? And I said, yeah, I've actually heard that from a bunch of neurologists. She says, this is the reason why. It's not the aspirin, because they've taken, truckloads of aspirin before and that didn't work. It's the sodium bicarb, because it's activating the vagus nerve. Now, obviously, there's limitations on how much sodium bicarb you can take safely. I think it's about 1,900 milligrams a day. And I said, well, there's a way to activate the vagus nerve that doesn't involve doing that. You can do it, with exercise. You can do it with deep breathing. You can do it with, cold plunges. You can do it with vagus nerve stimulators, with devices. And actually, one of the clinical applications that actually is FDA cleared with vagus nerve stimulation is migraines. So it's all coming back around. I love when the circle is now complete, as they would say.
Yeah. And that's, come on, that's one of the grandma's cures, right? You have it in the cupboard and if your stomach's upset, this will make you feel better, baby, And
now we know why. Just like chicken soup works, Chicken soup works because it's got all those short chain fatty acids in it, lots of butyrate and other good things to help heal the gut.
Absolutely. Collagenous type protein precursors too, with the lysine, proline, glycine. Yeah, absolutely. Yeah. That's great, man.
It correlates a lot with many of the inflammatory triggers, the food sensitivity crew that tends to be very acidic and very inflammatory and causing your body to go into that acidic state where sodium bicarb is an alkaline driver. It really pushes towards pH balance for those that are in a more acidic state. So really interesting way to kind of approach it. And we need that pH balance to have a regulated nervous system, which then works to in turn regulate the immune system, which in turn regulates the inflammatory cascade. So it just really goes down that pathway.
We've talked about the fact that, some very simple things like having to go to the bathroom, feeling that pressure, that urge, you got to go to the bathroom, being thirsty, being hungry. Yeah. Those things are very strong activators of the sympathetic nervous system. And we know that the sympathetic activation is associated with inflammation. And we know that parasympathetic activation is associated with rest, digest, restore, recover.
Right.
I wonder whether or not that high level of acidity, that low pH in the stomach, is actually not only maybe a suppressor of parasympathetic activity. I wonder whether it's an activator of sympathetic activity, because
interesting.
If so, that would make it a pro-inflammatory state.
Well, hold on though. Let's back up just a tad here, because
I may be going over the edge.
Yeah. Well, here's what I need to state as a clinician who's seen lots of people who are on PPIs, for example. So proton pump inhibitors like the omeprazole family will change the pH drastically, right? So normally, if you're lucky in the stomach, you're 1.7 or 1.9, you're below 2. And if you take a PPI, you'll shift your pH to a 5, right? So, 4.5 or above. So you're basically turning what used to be close to battery acid into table vinegar, right? So you're no longer digesting your food, you're now marinating your food. So I'm going to challenge that if we wanted to work through stomach acid, we might want to use vagal nerve, maybe not using the acid to a point of trying to sequester the acid all the time, because what I see in the use, and this is Eva Untersmeyer from Austria, she's been publishing data on this for a long time. 2004 is when I started reading her stuff. And basically she says, when you start shifting the pH at a 0.25 variation change, so if you went from a 2 to a 2.5, you'll see a massive increase of antigenic exposure, immune excitation, and presence of allergies, right? And we know that the immune excitation and allergies leads to histamine response in the brain, it leads to CGRP release. We know, so we don't want necessarily to lower the acid to a point where it's dysfunctional. If you're doing it away from food, that's one thing. But if you're trying to digest your food and you don't have enough acid, we know with the use of proton pump inhibitors, we'll end up with magnesium deficiencies. We'll end up with B12 deficiencies. There's that B12 associated with the methylation you were talking about. There's that magnesium associated with the ATP production, hypoxia issues that we were talking about. So we have to be cautious when we're looking at lowering the actual pH, or I should say lowering the acidity and raising the pH in the stomach, because there are always downstream effects of that as well.
Yeah, no, I think that's right. And I would think that vagus nerve stimulation as a means for doing it might be a little bit less aggressive than a PPI. Because
I would imagine so.
I mean, the PPI changing it from a 2 to a 5 is a lot more aggressive than even taking an Alka-Seltzer, because an Alka-Seltzer is going to move through the system. It's not permanently changing how the function of those proton pumps are going to for days. Right. So I agree with you. I think maybe PPIs are just maybe a little too strong, a howitzer to try to take down a bird.
Exactly.
What we need to do is to bring in something that's a lot more natural, because deep breathing exercises can activate the vagus nerve. So clearly it's going to be something that your body can tolerate. And right. I've actually personally experienced those hunger pains, because I like to do intermittent fasting. You get those pains where you're hungry, just simply taking, a bunch of deep breaths, and it goes away. It relaxes.
Yeah, I guess one of the challenges too I was trying to address is that we don't want people assuming that they have too much acid. So I had one of my good friends, Dr. Adam Geiger, do consecutive testing of close to 100 of his patients, whether they were, 7 to 92. And when he looked at the amount of people who actually had excessive acid, in the presence of symptoms of indigestion, so gas, nausea, bloating, feeling full after eating, whatnot, the amount of people who overexpressed was less than, 1, right? So it was a mild diminished area. So the chances of having too much acid, whether it's shown to you on your doctor's wall or on a commercial somewhere, is actually very, very rare. So the ability for you to produce too much acid takes a tremendous amount of energy, right? The omeprazole is actually the proton pump inhibitors, an ATP ACE inhibitor, right? It blocks energy production because the medication knows that it takes a tremendous amount of energy to make acid. So when you have low energy, you're probably not making too much acid, right? So it's an anomaly. I feel a clinician responsibility to say that piece as well.
Yeah, my focus on my comments there was on the blood pH levels, less so on the pH levels. But I think you got that point pretty clearly.
Oh, got it. No, I agree with both of you. I'm just saying that as listeners are listening, they might be thinking, "Oh, so lower the acid." And I'm like, wait a second. Nope. This is a very important component of normal digestion, absorption, and protection of the human body. So
yeah, and we've talked at length at the importance of gut function and that optimization of each step in the digestive process being driven by each of the
I've seen cases of MS initiated by long-term use of PPIs. I've seen all sorts of different things that, have contributed to severe nutrient deficiency. So I guess I'm a unique practitioner in that every chance I have, I convince a person to take a nutrient analysis test. So they'll look at plasma amino acids, plasma fatty acids, minerals. I like to look at the organic acids. I look at all of it to determine, if a person has been doing something for a long period of time, how is that serving their levels? And, I run these on migraine clients all the time, right? I just had one yesterday that I was looking at before I closed the practice last night. And holy smokes, she had this bizarre variation. She had a manganese deficiency, which we know, might be leading towards SOD, magnesium-associated mitochondrial SOD insufficiency, which can lead to that hypoxia, which leads to that whole issue with that threshold. She had some severe omega-6 to omega-3 imbalances. Her omega-3s were through the roof, but the omega-6s were low. And so we know phospholipid incorporation in the neurons, needs both the omega-3 and the omega-6s. So there was just a lot of different things that you would never guess unless you looked at the nutrient quantity, right? So one of the things I see, though, is chronic use of the PPIs. Holy smokes, we see B12, we see, a lot of the magnesium and minerals in general, zinc. But the biggest thing, which is nobody's looking at, is amino acids. When you have low acid, you have low amino acids. And, we need the serotonergic pathway working. Even the CGRP signaling system, has a serotonin component to it, right? So if we don't have enough of the tryptophan turning into, 5-hydroxytryptophan and then to serotonin and melatonin, then we throw off sleep, we throw off mood, we throw off inflammatory response in the brain and the gut. So there's just so many other, there's that web again, darn it. You start talking about one thing, it ties into everything, doesn't it?
and melatonin's role with mitochondria. I mean, it's such an important antioxidant and it triggers, one of the things we didn't talk about is that alpha-7 nicotinic acetylcholine receptor that is so important for the whole vagus nerve stimulation pathway. It's not just on the outside of the cell, it's on the mitochondria. And mitochondria respond to acetylcholine and melatonin. There's this three-part positive, I guess they call it a virtuous cycle. They reinforce each other. And when any one of them is not present, mitochondria start to fail.
Yes. They fail with irritation as well. So as we know, they shift over, right? So anytime they're so darn sensitive, if you look at the actual voltage sensitivity of a mitochondria versus any other part of the body, and specifically brain mitochondria, they're incredibly sensitive. So you can have one little thing shift and it will turn off that brain. You don't have the good function. So
but it's really important for us to be cognizant of that and to respect that sensitivity, because we wouldn't be here. Multicellular creatures wouldn't exist were it not for mitochondria. So it's amazing what they do.
They're incredible. Let's bring it back to Martha for a second, because she's such a lovely woman, Harvard neurologist, and she passed me at an autism conference that we were at together lecturing one year. She passed me a book called Terminus Brain. I don't know if you've heard of that one, but it's basically the premise of the book is we find ourselves to be so intelligent, right? And we invent all these wonderful things like motor cars and factories and chemicals that we use to make our lives better with chemistry, apparently. And in the process, the most susceptible tissue that we invented these substances with suffers from it. So we use our brain to invent these wonderful, quote unquote, wonderful things that are supposed to help us, and they end up harming us. They end up actually dulling the brain's capacity to even do further inventions, right? So we're ending up with this terminus brain where the brain has gone too much towards not even taking into consideration what its needs are. So if we went through life as a society, as a culture, as individuals, thinking to the least of our brethren, which would be the sensitive mitochondria, then perhaps we would reach some sort of state of purgatory, right? So we have to always think, what am I doing to the least of these? What am I doing to the brain mitochondria? And if I can keep that calm and I can keep that nourished, then life's going to be fantastic.
Couldn't agree more.
I love it. I think it's a great point to get to a close on. Tom, I want to give you an opportunity to just share a couple of closing comments, recommendations that you can provide. Where should people start if they're dealing with migraines, if they're dealing with some of these more challenging conditions? What's a good starting point? What are the top 3 things they can do?
Well, I think you guys are dead on. I think the stress response is massive. And I think if you can do the breathing techniques, if you can do, I'm finding success with, consistent exercise. If you can look at the potential irritants that might be coming into your life, whether that's coming from your diet, your stress, your toxins, your microbes, your allergens, if you can find the things that are going to stimulate that inflammatory response and you can diminish them, that seems to be incredibly helpful. If you can increase your nutrient status, maybe do nutrient analysis with a very skilled practitioner. It takes years to understand those darn things. If you can work on your sleep cycle, right? You can get some exercise, you can reduce that stress, and that's where your device comes in beautifully, as well as you can find some sort of love, connection, and purpose. So I'm finding that people who don't feel like they belong, they don't feel like they have a purpose, they feel like they're doomed to suffer from their migraines for the rest of their life, a little spark of hope does amazing things for helping them initiate all these other things. So if you have a person who responds well to your device, for example, that might give them that little bit of a jump that they need to find, all the other things in their life that they can find balance with. So it's a slow process. I would say be patient with yourself. You can have some pretty intense leaps and bounds when you take some interventions on, which is wonderful. And to find that, overall balance, just be patient. It might take you 8-12 weeks before you really see a big jump. But once you do, it's game on. I mean, my clients who, once they feel it and they're like, wait, what? I don't have to have migraines for the rest of my life? They're some of the most motivated people on the planet. So it's great. But when you're in that pain point, and you feel like the world's ending, it's hard to see that. But that is so temporary. You can make some simple changes and then entire thing reverses, and you can feel that fog lifting pretty quickly, and you can move forward. So
couldn't agree more, Tom. I really appreciate you joining us for this conversation and sharing such wonderful wisdom and knowledge gained over the years. Where can people find you if they're looking to get in touch with you or learn more about you and your practice?
Yeah, it's interesting. We're doing a site right now. So it's going to be migrainereliefmethod.com. And that's not quite complete yet. Well, by the time you launch this, it's probably going to be complete. But migrainereliefmethod.com/register if they want to watch, a webinar that I gave on the different aspects that I look at for migraine relief. That's a place to start as well.
Love it. Thank you so much again for joining us. And for anybody who's gotten to this point in the podcast, thank you for listening. And Tom, you've got one more thing there.
Migraine relief method. I said the method part, right?
You did. migrainereliefmethod.com/register.
Tech guys tried to convince me to launch a site with migrainerelief.com. And I'm like, it's migraine relief method. Let's go.
Method. You got to get the method in there because you need a pathway to get to the end point.
There is a method to the madness.
I love it. Wonderful. Thank you again. If you got to this point in the podcast, would love to have you share this episode with just one person that you think could utilize this information to change their life and upgrade their health. Thank you so much and have a wonderful day.